Today we're going to begin a new unit, and the unit is on matter and atoms. So the name of the unit is What's the Matter? So we're going to be looking at the three states of matter and what things make up all things that take up space. So your essential question is, what are the three states of matter and how are they different? So we're going to look at the three different states of matter and how each of these have different characteristics and how their particles react. So the first thing we need to talk about are atoms, those basic building blocks. So atoms are going to be the basic building blocks of all matter. So matter is going to be made up of these things called atoms. The picture at the bottom is the structure of an atom. So an atom is composed of protons, neutrons, and electrons. And those protons and neutrons we're going to talk about a little bit in just a second and where they're located. So we're going to take a look at that structure as well. Okay, so let's first look at the parts of an atom. There are three parts of an atom, okay? The first part of an atom is a proton. It is located in the nucleus of an atom. Second part of an atom is a neutron. Neutrons are located in the nucleus of an atom also. The third part of an atom is a little bit different from the others. Electrons are not located in the nucleus. They are located around the nucleus, and we'll talk about their locations in just a second. Protons are going to be those things that are positively charged in an atom. Protons are going to be located in the nucleus of an atom, and we'll talk about the nucleus for just a second. The nucleus is the center part of that atom in that picture. So if you remember from the picture, from the atoms slide, the blue and the red portion, that is the nucleus of an atom. It is that control center of that atom. Okay? A neutron is also located in the center of an atom. Neutrons have no charge, okay? So they're different from protons and electrons. They have no charge. So in parentheses, I have written zero charge because there's no charge in a neutron. It's located in the nucleus of an atom, so that center portion with those protons, okay? So neutrons are located in the center with the protons. Electrons are different in that they are not in the nucleus of an atom and they are negatively charged. So there's a negative sign in the parentheses. They are located on the outside of the nucleus of an atom. So those elliptical circles you saw around the nucleus, those were called orbitals, and the electrons are actually located on those orbitals, and they kind of revolve and center around the nucleus of an atom. So now that we've talked about atoms, okay, and their makeup and how they make up matter, okay, we're going to talk about matter, okay? So matter is actually anything that takes up space. Okay, so anything that you can think of that takes up space, the desk you're sitting in, you are composed of matter. The brick walls that you see around you, the floor, everything around you is matter, okay, that takes up space. The air that you're breathing. Can you think of anything else that I didn't name that could be an example of matter? Let's talk a little bit now about the three states of matter. So there are three different types of matter, okay? You probably already heard or know this, but the three states of matter are solids, liquids, and gases. So we're going to take a look at what solids, liquids, and gases are. We're going to look at their structure. We're going to look at how they're different from each other and why they act or look the way they do. Okay, so first let's look at solids. Solids are anything that has definite shape and a definite volume, okay? So basically you would be able to measure its volume, okay? You would see that it is shaped in a specific way. Those atoms are going to be very, very attracted to each other, okay? So if you take a look at this structure, which is a solid, what do you notice about the particles? And by particles, I mean those little circles. So think of little tiny circles are going to be within a solid structure. So the disk that you're sitting in, think about that for a second. Those tiny particles are inside of that disk, those little circles. What do you notice about those particles that are presented in the picture that I just displayed, this picture? If you look at them, those particles are very, 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 very close together, and that's because they're very attracted to each other. They want to be close together, and that's what makes solids what they are. So a solid ice cube would be an example of a solid, okay? And those particles are very, very close together. Let's look at liquids next. Liquids, they're going to have a definite volume because you can measure the volume of a liquid, but they don't have a definite shape. Think about a glass of water, okay? Water is a liquid, and if I pour that into a heart-shaped glass, it takes the shape of its container, okay? So it doesn't have a definite shape, okay? So we can't say that water is cube-shaped, okay? Water molecules are a little bit different from solid molecules, okay? They are close together, but not as tightly packed. So what are the differences between solid particles and liquid particles? Think about that for a second. What are the differences between solid particles and liquid particles? If you said in your mind that the solid particles are closer together and more tightly packed than those of liquids, then you are correct. Liquid particles are going to be very, very loose, and that's because of the movement of water, okay? So they kind of roll past each other, but they don't stick together as cohesively as a solid. Now we're going to take a look at gases. Gases are very different from solids and liquids in that they have no definite shape and no definite volume. The reason that they have no definite shape and no definite volume is because those atoms are very far apart, okay? And they're far apart because the attraction between those atoms are very, very, very weak. And so they are not attracted to each other, and they're going to move freely past each other. So if I ask you to differentiate between the particles of a solid, liquid, and a gas, what would you say? If you guys said that solid particles are very tightly packed and close together, you're correct. If you said that liquid particles, they're close together but not as tightly packed as a solid, you are also correct. If you say that gas particles are very far apart and not close at all like liquids and gases, you are very correct as well, okay? So let's take a look at the movement of the particles of solids, liquids, and gases. Okay, when we look at particle movement, we're looking at, we're going to assume that all particles in solids, liquids, and gases, so all matter, are moving at some rate, okay? It could be slow, could be fast, and we'll get to temperature, which affects the movement of particles in solids, liquids, and gases in another lesson. So when we look at particle movement of a solid particles are going to vibrate, but they don't move past each other, okay? And that's because they're very close together, okay? So when we look at the particle movement of a liquid, they vibrate, but they're able to kind of slide past one another. Think about why that's so. Okay, in a liquid, they're not as tightly packed as that of a solid. And because they're not as tightly packed as that of a solid, they're able to kind of slide past each other. Okay, so let's look at gases. Okay, gases, they're going to vibrate but move freely past each other. Why do you think they do that? Yes, if you said that basically the gases move freely past each other because they're so far apart, you're correct. So we're going to take a look at different solids, liquids, and gases and talk about their particles. We're going to make some foldables in this unit to help us to understand particle movement. And we're also going to do different labs to understand how solids can become liquids and liquids become gases. So we're going to take a look at each of those in this unit.